Have you ever stared at an Excel spreadsheet, feeling that familiar knot in your stomach? That mix of dread at the complexity, but also awe at the sheer power it holds.
Yeah, I think we've all been there.
You are absolutely in the right place then. Our mission today is to cut through that complexity, giving you a real shortcut to mastering Excel, transforming it from, a source of frustration into a wellspring of insight. And here's a crucial mindset shift right off the bat. Those error messages you sometimes see, they aren't failures. In fact, they're the opposite. They're welcome clues.
Exactly. Think of them not as a roadblock, but as Excel trying to whisper, sort of, exactly what went wrong and maybe how to fix it.
Okay.
Our goal in this deep dive is to demystify Excel's core concepts. We'll go from its fundamental structure to getting data in efficiently, then to the powerful calculations it can do.
Right.
How to interpret those clues, the errors, and finally, how to make your data truly shine. You'll gain a foundational understanding that empowers you to leverage Excel's full potential and, crucially, avoid feeling overwhelmed.
Okay, let's start at the very beginning then. When you open Excel, what are you even looking at? What is a spreadsheet, really?
Well, at its heart, a spreadsheet is basically a computer application for organizing, analyzing, and storing data in a tabular, grid-like form.
Like a grid.
Yeah, imagine those old-school paper accounting ledgers, but supercharged and inside your computer. It's all built around these individual boxes, these containers of information we call cells.
And those cells are key, aren't they? It's basically a giant digital grid. You've got rows typically numbered 1, 2, 3, and columns identified by letters like A, B, C. So if you want to find a specific piece of info, you're looking for a unique address like, say, C10, where column C meets row 10.
Right. It's a very logical system, C10 exactly.
It is.
And while individual cells are important, you rarely work with just one. More often, you're dealing with a range, basically a block, a collection of connected cells.
Okay.
We describe a range by its top left and bottom right corners. So, for example, A1 taught A10 means every cell from A1 right down to A10 in that column.
Now, here's something that I think blows some people's minds. Most people think of Excel as just one giant sheet, but a single Excel file, what we call a workbook, can actually contain multiple sheets or worksheets.
Yeah, that's a really important distinction.
It's like having several related pages or ledgers all in one book. And if you need to pull data from another sheet, you just add the sheet's name to the cell reference, right? Like sheet 1.c10.
Exactly. Sheet 1.c10. It keeps everything organized but connected. It's incredibly flexible.
Okay.
Right. And knowing your way around the program itself, the interface, makes a huge difference. When you open Excel, you'll see those tabs like Home, Insert, Formulas running across the top. Clicking on any of these changes the ribbon directly below it. And the ribbon is essentially this big toolbar full of buttons specific to what that tab does.
Yeah, the ribbon can look a bit overwhelming at first. But you'll notice within each ribbon, tools are neatly divided into groups, like the font group or alignment group on the Home tab. Makes it easier to find things.
Definitely. And sometimes you'll spot a tiny little square button with an arrow, often in the corner of a group. That's a launch button.
Oh, okay.
That's your kind of secret doorway to even more advanced options that don't quite fit on the main ribbon.
Got it. And above the main grid, that long white bar.
That's the formula bar. Super important. That's where you'll type and edit all your calculations, your formulas.
Okay.
And just to its left is the name box, which simply shows you the address, like C10, of the cell you currently have selected. Or maybe a name if you've named the cell.
And of course, you've got your standard scroll bars for moving around large sheets, and that zoom slider, usually in the bottom right, to zoom in or out. Doesn't change the data, just your view.
Right, just the view.
And for anyone who uses Excel a lot, the quick access toolbar at the very top left, that's a lifesaver. You can stick your most used buttons up there, like save or undo.
Yeah, you can customize it.
Saving you a ton of clicks. Understanding this foundational layout is truly like learning the dashboard of a car. Once you know what stuff does, you're ready to actually use it without feeling lost.
Exactly. So once you understand the layout, the next step is getting data into those cells efficiently. And the core principle in Excel is pretty simple. Select to effect.
Select to effect,
Meaning, to do anything to a cell, change it, format it, whatever, you first have to click on it to select it.
It sounds basic, but it's fundamental. Once selected, you just start typing your data. Pressing Enter is your default move, right? That usually takes you down to the next row.
Yep, down one row. Great for entering lists.
And if you want to move to the cell next door, to the right,
you hit Tab, Tab moves right, Enter moves down.
And if you ever need to go backwards, like up or left?
Easy. Just hold down Shift. So Shift plus Enter moves you up, and Shift plus Tab moves you left. Simple, but surprisingly useful once you get the hang of it. And this is where I think the magic really begins. The fill handle. Have you noticed that tiny green square in the bottom right corner of a selected cell or range?
Oh, yeah, the little square.
That's the fill handle. It's basically a drag-and-drop wizard. It helps you extend data patterns or just copy information across your worksheet with incredible speed.
It's brilliant, isn't it? And Excel is actually quite smart about it. For numbers, if you wanted to continue a sequence, like 1, 2, 3, you usually need to give it 2 examples first, right? Like type 1 in one cell, 2 in the next.
Exactly. Select both.
Then drag the fill handle. Otherwise, if you just drag from a single number, it often just copies that same number over and over.
Right. Unless you hold down Control sometimes. But yeah, 2 numbers sets the pattern, like 1 and 3 if you want odd numbers.
But for dates and times, Excel is even smarter, isn't it?
It is. Give it just one date, say today's date, and drag the fill handle, and it'll automatically increment by 1 day. Same with times. Give it 9:00 a.m., drag it, and you'll get 10:00 a.m.
Wow, okay. That's a huge time saver.
Oh, absolutely. And that fill handle isn't just for simple data. It's fundamental for copying formulas, too. When you drag a formula down, Excel automatically adjusts the cell references inside that formula for you. We'll talk more about how it adjusts them later. That's relative references.
Okay, that sounds important.
It is. Plus, here's a pro tip. If you have a column of data right next to where you want to autofill a formula or sequence, just double-click the fill handle instead of dragging. Bam! Excel will instantly fill down that column, stopping automatically when it reaches the end of the adjacent data.
Whoa, that double-click trick is amazing. Seriously useful for long lists.
Totally. But you can take it even further with custom autofill lists. Imagine you always type the same list of employee names or maybe product categories or days of the week in a specific order.
Okay.
You can teach Excel that list. You set it up once it's buried a bit, in File, then Options, then Advanced. Find the button that says Edit Custom Lists.
Okay, File, Options Advanced, Custom Lists.
Once it's set up, you just type the first item from your list, grab the fill handle, drag it, and Excel fills in the rest automatically. Perfect for consistency and speed.
That's really cool. So beyond just getting data in, what about managing what's already there? Editing stuff.
Right. Key difference. If you click on a cell and just start typing, you'll completely overwrite whatever was in there.
Okay, wipes it out.
Yeah. But if you want to edit the existing content without erasing it all, you can either double-click right inside the cell or click the cell once, then click up in the formula bar, then you can make your changes.
Got it. Double-click in the cell or use the formula bar for editing. And copy-paste is standard stuff, right? Ctrl plus C, Ctrl plus V.
Yep. Ctrl plus C for copy, Ctrl plus V for paste, and Ctrl plus X for cut if you want to move it. But here's another way to move stuff. Click on a cell, then move your mouse to the edge of the cell until the cursor changes to like a 4-way arrow.
Oh, yeah, I've seen that.
Then just click and drag the cell wherever you want it to go. Simple move.
Nice. And if you just want to delete the data, hit the delete key.
Delete key usually just clears the contents, the data itself. But if you want to wipe everything the data in any formatting, like colors or borders, you need the Clear All option. It's on the Home tab in the Editing group, usually under a little eraser icon.
Okay, Clear All wipe. All for the full wipe. Good to know.
Absolutely. And keeping spreadsheets clean and readable means organizing them effectively. Inserting rows or columns is easy.
How do you do that?
Just right-click directly on a row number on the left or column letter at the top and choose Insert. Adds a blank row above or a blank column to the left.
Simple enough. And you mentioned making columns fit their content earlier.
Yeah, the auto size trick. This makes things look so much better. Select multiple columns by clicking and dragging across their letters at the top.
Okay, got them selected.
Now, just move your mouse to the boundary line between any 2 of those selected column letters and double-click.
Double-click the line between them.
Yep.
Boom. Excel instantly resizes all the selected columns, so they're just wide enough to fit the longest piece of text in each one.
That is like magic. Seriously, that's a great tip.
It really is. Now, for updating info that appears multiple times, Find and Replace is your friend. Shortcut is Ctrl plus H.
Ctrl plus H. Okay.
You can quickly find specific values, say an old price, and replace them all at once with a new one. Super useful for, like, updating a standard hourly wage across many entries.
But be careful with that one, right?
Oh, absolutely. Always exercise caution. If you blindly replace a common number, say 15, you might accidentally change an employee ID that happens to be 15 or part of an address. Always good to review the replacements or use the Find Next button first.
Good warning. And on the topic of typing, what about typos? Does Excel help with that?
It does. Excel has autocorrect options, just like Word. You can find them under File, then Options, then Proofing.
Ah, proof it. You can configure it to automatically fix common typos as you type. Even better, you can set up your own shortcuts, like typing Q1 could automatically expand to Q1 sales report.
Oh, that's clever.
Yeah, think about how much time that could save on repetitive text entries. All these little techniques, data entry, the fill handle, organizing, autocorrect, when you put them together, they fundamentally transform how efficiently you can work in Excel. Saves tons of time.
Totally. Okay, so we've got data in, it's organized. Now let's talk about the real engine room.
Yeah.
Formulas and functions.
Yes. This is where Excel really shines. I mean, it's great for organizing data, yes, but its real power lies in its ability to perform incredibly sophisticated calculations. It's essentially the world's most powerful calculator right there.
And the absolute golden rule, the first thing you must remember for any calculation in Excel.
It must begin with an equal sign.
Yeah.
Always. That equal sign is a signal to Excel. It says, hey, pay attention. What follows isn't just text. It's a calculation or a function I need to process.
Got it. Equal sign first. Always.
Always. You can start simple using what we call constants, just numbers you type directly into the formula, like 105.
Okay, simple math.
Exactly. And you use the standard arithmetic operators you learned in school, plus for addition, for subtraction, for multiplication, for division. There's also for exponents or power of.
Right. But the real power comes when you stop using those constants, those direct numbers, and start using cell references, right?
Absolutely. This is the game changer. Instead of typing 105, you'd maybe put 10 in cell C2 and 5 in cell D2, and then your formula becomes C2D2.
Okay, so it refers to the cells containing the numbers. Why is that better?
Because it makes your formulas dynamic. If you later change the number in cell C2, maybe becomes 12, your formula result in, say, E2 automatically updates. You don't have to rewrite the formula. This is crucial for building flexible spreadsheets or models.
Ah, I see. That makes total sense. Changes flow through automatically.
Exactly, and this leads us to a really, really important concept. Understanding the difference between relative and absolute cell references. This can be a bit tricky at first, but it's essential.
Okay, break it down for us. Relative first.
Okay. By default, Excel uses relative references. This means when you copy a formula from one cell to another, Excel cleverly adjusts those cell references based on the new position.
How does that work?
So imagine in cell E3, you have the formula C3D3. If you copy that formula down one cell to E4, Excel automatically changes it to C4D4. It assumes you want to perform the same relative calculation for the new row.
Ah, okay, so it shifts down with the formula. That's usually what you want.
Usually, yes. But what if you don't want a reference to change? Let's say you have a fixed tax rate in one specific cell, maybe H1, and you want to multiply a whole column of sales figures by that exact tax rate.
Right. You don't want the tax rate cell reference to shift down when you copy the formula.
Precisely. That's where absolute references come in. You lock a cell reference by putting dollar signs before both the column letter and the row number, like H1 dollar.
Dollar signs. Okay.
That tells Excel, hey, always refer to this exact cell, H1, no matter where I copy this formula.
That's super useful. Is there a quick way to add those dollar signs?
Yes. This is a great shortcut. When you're editing your formula and your cursor is on or next to the cell reference, like H1, just press the F4 key on your keyboard.
F4.
Yep. Press it once, it makes it absolute, H1 dollar. Press it again, it might lock just the row, H1 dollar. Again, just the column, H2 dollars. And again, back to relative H1, it cycles through the options.
F4 key. Got it. That's much faster than typing dollar signs.
Definitely. There are also mixed references, H dollars or H1, or where you lock only the column or only the row, which are useful in more complex scenarios. But understanding relative default versus absolute is the core concept.
So this whole relative versus absolute thing is fundamental for copying formulas correctly, especially with fixed values.
Absolutely fundamental. It empowers you to build robust formulas that you can reuse without breaking. Essential skill.
Okay. Now, what about more complex formulas with multiple steps? Does Excel know what to do first?
It does. It follows the standard order of operations, sometimes remembered by acronyms like PEMDAS or BODMAS, basically. Parentheses first, then exponents, powers, then multiplication and division, working from left to right, And finally, addition and subtraction, also left to right.
Right, just like in math class.
Exactly. And those parentheses are your tool to control the order. If you want to force Excel to add two numbers before multiplying, you put the addition inside parentheses, like A1 plus B1C1.
Got it. Use parentheses to control the calculation order.
Precisely. Now, beyond the formulas you build yourself using operators, Excel has this massive built-in library of functions.
Okay, functions. What's the difference between a formula and a function?
Good question. Think of it this way. Formulas are the equations you write using operators and cell references, like C2D2. Functions are like predefined, ready-made formulas that Excel already knows how to perform for specific tasks. They save you having to write out complex calculations yourself.
Ah, okay, so they're like calculation shortcuts. What are some common ones?
Oh, there are tons, but some you'll use all the time. SUM is probably the most famous. It just adds up all the numbers in a range. Instead of typing D2 plus D3 plus D4 plus D5 all the way down to D71, you just type SUM D2.D71.
Much easier.
Way easier. And there's even a button for it. The AutoSum button usually looks like a Greek sigma. Click it, and Excel often correctly guesses the range you want to sum.
Nice. What else?
Average calculates the average of numbers in a range. Max finds the highest value in a range. MIN finds the lowest value. And count simply counts how many cells in a range actually contain numbers. It ignores text or blanks.
SEM, average, max, MNN. Count. Okay, those sound like the everyday workhorses.
They really are. And remember, ranges. To make your formulas with functions even easier to read and manage, especially in big spreadsheets, you can use named ranges.
Named ranges, you mean give a block of cells a name.
Exactly. Instead of remembering that your quarterly sales figures are in cells D2 through D71, you could select that range and give it a name, like quarterly sales.
How does that help with functions?
Well, now your formula becomes SEMHEM quarterly sales. Instantly understandable, right? Much clearer than SUM D2 D71.
Yeah, that's much more readable. I like that.
It makes managing complex sheets way easier. And you can even get fancier by nesting functions using one function inside another.
Whoa, okay. Like what?
A common example is rounding. Say you want to sum a range but show the result as a whole number. You could use round SEMHEM B2.B60. The SEM function calculates the total first, and then that result is fed into the round function to round it to 0 decimal places.
Okay, nesting functions. That opens up possibilities.
It does. There are also more advanced things like array formulas and user-defined functions, but mastering basic formulas, cell references, and common functions like SOM, average, etc. is what truly unlocks Excel's computational power for most users. It lets you automate tasks and perform really dynamic analysis.
Makes sense. It's about making Excel do the heavy lifting.
Exactly. Let the calculator calculate.
Okay, so we know how to make calculations, but sometimes things go wrong. You get those weird messages starting with a hash symbol.
Yes, the error message.
They can be jarring. But you said earlier, don't panic.
Absolutely not. Please remember, seeing an error message is not a failure on your part. It's just Excel's way of giving you a welcome clue, a hint about what went wrong in your formula or data. Take a deep breath. Don't get frustrated.
Think of them as diagnostic notes, not insults.
Precisely. They're trying to help. For instance, one you'll see a lot is just a bunch of hash symbols. Hashtag.
Yeah, what does that mean?
It almost always just means your column isn't wide enough to display the full number or date that's the result of your formula. The fix is usually super simple. Just make the column wider. Drag the boundary between the column letters.
Okay, hashtag just means needs more space. Easy fix.
Usually. Occasionally can mean a negative date time value, which Excel can't display, but mostly it's column width. Another classic is hashtag div0.
Divide by 0.
Exactly. Your formula is trying to divide a number by 0, which is mathematically impossible. You need to look at the cell that's acting as the divisor. Is it empty? Does it actually contain 0? You need to correct that divisor.
Or maybe hide the error if sometimes division by 0 is expected.
Yeah, if it's okay for it to happen sometimes, you could wrap your formula in an IFOR function. We can talk about that more later.
Okay. What about hashtag name?
Hashtag name. Okay. Almost always means Excel doesn't recognize something you typed, usually a function name. Did you spell SUM correctly? Or maybe you put an equal sign in front of text that isn't actually a function or named range.
So check spelling first for hashtag name E.
It's definitely the first check. Then there's hashtag REF. This one's common too.
REF. Like reference.
Exactly. It means your formula contains an invalid cell reference. This typically happens if you've deleted a cell or maybe a whole row or column that your formula was previously pointing to. The link is broken.
So the cell it was looking for is gone. What's the fix?
The quickest fix is often to immediately hit undo, Ctel plus Z if you just deleted something. Longer term, using absolute references or named ranges for critical cells can sometimes prevent #REF errors if you're reorganizing your sheet.
Okay, so undo or rethink the references.
Yeah.
And #value, that sounds kind of vague.
#VLUE usually pops up when there's an unexpected type of data in your formula. Like you're trying to do math plus detail on a cell that contains text instead of a number.
Trying to add apple to 5.
Exactly. Or maybe you've used a function incorrectly, giving it the wrong type of argument, like text where it expects a number. Or maybe you skipped a required argument. Just double check the formula syntax and make sure your data types are compatible with the operation.
So #tag is with, #div0 is dividing by 0, #known e is spelling, #ref is a broken link, and #value is a data type mismatch. That covers a lot of them.
Those are the big ones. There are others like #NUM, #NLL, #spill, but understanding these core ones gets you a long way. And remember, Excel often tries to help you debug.
Wow.
See that little green triangle that sometimes appears in the top left corner of a cell with an error?
Oh, you have a little flag.
Hover over that or click the cell and often a little warning symbol appears. Click that and you might get options like trace error, which can give you more details or even point to the problematic part of the formula.
Okay, look for the green flag.
Yep. And for deeper dives, there's a whole formula auditing group of commands on the Formulas tab on the ribbon. Tools like trace precedence and trace dependence can visually show you which cells feed into your formula and which other cells depend on its result. It helps untangle complex calculations.
Formula auditing. Sounds useful for complex sheets. Now, you mentioned hiding errors earlier with IFER.
Right. Sometimes you might anticipate an error happening, like the #div0, and you don't want the ugly error message displayed. You can wrap your original formula inside the IFER function.
How does that work?
You type IFER, your original formula, valueFER. So if your original formula works fine, Excel just shows its result. But if it results in any error, Excel shows whatever you put in valueFER instead. That could be a 0, a dash in quotes, or even just blank double quotes for an empty cell.
Okay, so IFER A1B1 0 would show 0 instead of #div0.
Exactly. There's also IFNA, which is similar but only catches the #NA error, which often comes from lookup functions when a value isn't found. IFER catches everything.
But be careful just hiding errors, right?
Yes, definitely use it judiciously. Hiding an error might make your sheet look cleaner, but it could also conceal a genuine underlying problem in your data or logic that actually needs to be fixed. So use it when you expect the error and have a valid reason for it, not just to sweep problems under the rug.
Good advice. Understanding these common errors and how to approach them really helps you troubleshoot effectively, keep your data accurate, and ultimately make better decisions based on reliable numbers.
Couldn't agree more. Okay, so your data's in, your calculations are running, maybe you've fixed a few errors. The next step is polishing things up. Let's talk about data types and formatting.
Why are data types so important? Isn't a number just a number?
Not quite in Excel's world. How Excel interprets your data, whether it sees it as text, a number, a date, etc., is absolutely critical. It directly affects whether your formulas work correctly and how your analysis behaves. Get the data type wrong, and your calculations can break or give weird results.
Okay, so what are the main types?
Well, the most fundamental is probably text. This includes letters, obviously, but also numbers or symbols that Excel treats as non-numerical characters. You can type numbers as text, for instance, often by putting an apostrophe before them.
And the key thing about text.
Crucially, text cannot be used directly in standard mathematical calculations. If you try to SU a range where the numbers are actually stored as text, SUM will probably ignore them, giving you a result of 0.
That's a common frustration. Why is my SUM 0? Maybe the numbers of text.
Exactly. That's often the culprit. Then you have the number data type. This covers your standard numerical values, decimals, percentages, and importantly, dates and times are also stored as numbers under the hood.
Dates or numbers? How does that work?
It's actually pretty clever. Excel stores dates as sequential serial numbers. Day number 1 is January 1st, 1900. Today's date is just a much larger number representing the days elapsed since then. Times are stored as fractional parts of the day.
Wow, okay. That's why you can do math with dates, like subtracting one date from another to find the number of days between them.
Precisely. Then you have logical or Boolean values, which are simply true or false. These often result from comparison formulas, like checking if A1 is greater than B1.
True or false. Got it. And error types.
Yeah, those error values we just discussed, hashtag value, hashtag ref, etc., are technically their own data type as well. They're signals.
And I heard about newer types, linked data.
Yes, that's a really cool feature, mostly for Microsoft 365 subscribers. Linked data types like stocks and geography. You can type, say, Microsoft or Seattle, convert it to the linked data type, and then pull in live, up-to-date information directly from online sources like current stock price, company HQ, city population, etc.
Whoa, live data feeds. That's powerful.
It really is.
Yeah.
Now, related to data types is formatting. This is how the data looks in the cell, which might be different from how it's stored.
Like the date number versus how it appears, like June 18, 2025.
Exactly. You can take a number and format it to look like currency, $123.45, a percentage, 50%, a specific date format, or just a plain number with a certain number of decimal places. You do this typically using the number formatting options on the Home tab.
And formatting affects text, too, right? Align.
Yep. By default, Excel usually left aligns text and right aligns numbers, but you can change that. You can center titles, wrap long text within a cell, change font styles, bold, italics, font sizes, and add background colors or borders to make things clearer and easier to read.
So formatting is key for readability. Were there any quick formatting tricks?
Definitely. The Format Painter is your absolute best friend for consistency. See a cell whose formatting you love, maybe it's bold, currency, and has a specific background color.
Yeah.
Click that cell once, then click the little paintbrush icon, Format Painter, on the Home tab. Now just click on another cell and bam, all that formatting is instantly applied.
Oh, nice, like copying the style.
Exactly. And if you double-click the Format Painter button instead of single-clicking,
Double-click.
it stays active, allowing you to click on multiple different cells, one after another, applying the same formatting to all of them until you press Escape or click the button again. Incredibly efficient for applying a style repeatedly.
Double-click the Format Painter to paint multiple cells.
Ooh.
Awesome tip.
Yeah, it's a huge time saver. Ultimately, effective formatting isn't just about making your spreadsheet look pretty, though that helps. It significantly enhances readability, it helps communicate your data clearly, and it can even help ensure precise calculations by making sure you and Excel agree on what type of data you're looking at. It makes your work much more professional and impactful.
Absolutely. Okay, so we've got data, calculations, error handling, formatting. What about taking it beyond the grid? Showing results, sharing them.
Right, because often the goal isn't just to have the numbers, but to communicate insights from them. And one of the simplest, most impactful ways to visualize your data is by creating charts.
Charts can seem intimidating.
They don't have to be. Here's the very easiest way to make a quick chart. Just select the data you want to chart, including the labels or headers.
Okay, selected the data range.
Now just press the keyboard shortcut, Alt plus F1.
Alt in F1.
Excel will instantly create a default chart, often a column chart, based on your data, usually on the same worksheet. It makes its best guess at what makes sense, and honestly, it's often surprisingly good as a starting point.
Alt plus F1 for an instant chart? I like that. Can you change it easily?
Oh, yeah. Once the chart is created, you'll see new Chart Tools tabs appear on the ribbon when the chart is selected. From there, you can easily change the chart type to a line chart, pie chart, bar chart, whatever fits best, tweak colors, add chart titles, label your axis full customization.
Okay, so Alt plus F1 gets you started fast, then customize. Good approach. What about summarizing really big, messy data sets? Charts might get too busy.
That's where pivot tables come in. They are an incredibly powerful statistics tool built right into Excel.
Pivot tables. I've heard of them, but they sound complicated.
They can seem that way at first, but the basic concept is simple. They let you summarize and reorganize huge amounts of data dynamically without changing your original source data at all. You can pivot the data, hence the name, to look at it from many different angles.
What kind of summaries can they do?
All sorts. You can quickly calculate sums or averages like show me total sales broken down by department and by quarter, or show sales for each product as a percentage of the grand total. You can generate lists of unique values from a column, create quick cross-tabulations, like a 2x2 summary, identify top or bottom performers.
Wow, okay. That sounds way faster than trying to build complex SUMAF formulas or something.
Infinitely faster and more flexible for that kind of summarized reporting. If you're dealing with large tables of transactional data, pivot tables are often the best way to get quick, meaningful insights. Definitely worth learning the basics.
Okay, pivot tables for summarizing. Now, what about actually getting your work out of Excel? Printing or sharing?
Right, gotta show the results. Always start with print review. Go to File, then Print. This shows you exactly how your spreadsheet will look on the printed page, saves paper, and avoids nasty surprises.
Good tip. What if it doesn't fit right? Too wide, maybe?
You have options under page layout. You can easily change the orientation from the default portrait, taller, to landscape wider to fit more columns across the page.
Okay, landscape for wide tables.
And for really fine control over where pages break, use the page break preview mode. It's usually under the View tab. It shows your sheet with dashed blue lines indicating the current page breaks, and you can actually click and drag those lines to force breaks where you want them.
Oh, you can manually set the breaks. That's useful.
Very useful. There's also custom scaling under the print settings. You can try to fit sheet on one page, but be careful.
Not careful.
If you have a lot of data, forcing it onto one page will make the text incredibly tiny and basically unreadable. Sometimes it's better to let it span multiple pages cleanly.
Makes sense. What about sharing electronically? Is PDF the way to go?
Saving as a PDF is an excellent option for sharing. It creates a self-contained document that looks the same for everyone, regardless of whether they have Excel, and it locks down your formatting. Great for reports or emailing. You can usually find Save as PDF or Export to PDF under the File menu.
Okay, PDF for sharing finished reports. What about collaborating or just sending the file?
Excel usually has a built-in Share button, often near the top right. This can let you upload the workbook to OneDrive or SharePoint for online collaboration, or sometimes directly attach the workbook to an email, either as the original Excel file .xlsx or as a PDF.
So multiple ways to share depending on the need.
Exactly. And don't forget Save As under the File menu. This lets you convert your Excel workbook into other useful file types. You could save it as a CSV, separated values file, which is a very simple text format good for exporting data to other systems, or maybe even save as an HTML web page, or save your structure as an Excel template .xltx to reuse later.
Lots of options beyond just the standard Excel file. So charts, pivot tables, printing, PDFs, sharing. These tools really extend the reach and impact of your analysis, making it digestible and actionable for others.
That's the goal. Turn data into understanding and then share that understanding effectively.
Now, we've talked a lot about how powerful Excel is, and it truly is. But it's also really important, I think, to understand its, let's call them, hidden dangers, or maybe just inherent shortcomings.
Absolutely. For all its strengths, Excel isn't perfect. And having a balanced perspective, acknowledging where it falls short, is crucial for using it safely and critically, especially for important decisions.
So what are some of the main concerns? Reliability.
That's a big one. There's quite a bit of research on this, and some estimates suggest that around 1%, maybe even higher in some contexts, of all formulas in operational spreadsheets actually contain errors.
1%. That sounds low, but in a complex sheet with thousands of formulas.
It means there are likely dozens of errors lurking. And what's really eye-opening is studies comparing spreadsheet auditors. They found that auditors who meticulously check both the numerical results and the cell formulas don't actually find significantly more errors than auditors who only check the final numbers.
Wow. So even careful checking can miss formula errors. Why is that?
It highlights just how difficult and non-transparent spreadsheet logic can be to audit thoroughly, and a big contributing factor is often a lack of formal training. Many people rely heavily on Excel daily, but have never received proper instruction on best practices or error checking.
And maybe internal departments don't always have robust checks in place either.
That's often the case. It can create a sort of perfect storm for unnoticed errors to creep in and persist.
What about structural limitations? Things Excel just isn't great at.
Well, implementing truly complex models can become incredibly tedious. You're dealing with potentially hundreds or thousands of cryptic cell addresses like AZ57, trying to remember what each one means. It demands intense attention to detail.
Right, unlike maybe programming where you can use meaningful variable names.
Exactly. And related to that is formula repetition. In traditional programming, if you want to do the same calculation on 1,000 items, you write a loop. In Excel, you often end up writing nearly identical formulas 1,000 times, maybe just dragging the fill handle down. Array formulas can help, but it's still a different paradigm.
And what if the structure of your data needs to change fundamentally?
That can be a nightmare. Adding or removing a whole dimension of analysis, say, adding regional data to a model that was only national before is often so difficult to retrofit into an existing complex spreadsheet that you basically have to start over from scratch.
Ouch. Rebuilding sounds painful.
It can be, and collaboration on the logic itself, on the formulas at the cell level, can still be quite challenging compared to collaborative coding environments, although cloud versions are improving this.
Then there are data management and security issues.
Big time. People forget that older Excel formats, the .xls files used before Excel 2007, had a hard limit of just 65,536 rows.
65,000? That sounds like a lot, but maybe not for big data sets.
Exactly. There was that famous case in the UK during the pandemic where they were using an old Excel format for COVID-19 test tracking, and they literally hit the row limit. New cases reported after that point were simply cut off and not recorded initially. A critical data loss due to a simple, outdated file format limit.
Wow. That's a stark example. What else?
Critically, spreadsheets often lack robust auditing and revision control. It's very difficult, often impossible, to definitively track who changed what specific value or formula and when they changed it. This is a huge problem for regulatory compliance in many industries, and it dramatically increases the risk of errors or even fraud going undetected.
No clear audit trail.
Right. And combine that with a general lack of security. While you can password protect files, the controls over who can see or modify specific parts of the data within a sheet are often quite limited compared to databases. This increases the risk of both accidental mistakes and intentional manipulation.
So because they're so flexible and, well, unstructured in a way.
Yeah. It's remarkably easy for someone to introduce an error, either accidentally by typing over a formula or maybe even intentionally to manipulate results.
And all these things together contribute to what's called spreadsheet risk.
Exactly. Spreadsheet risk is defined as the risk of deriving a materially incorrect value from a spreadsheet, which then leads to a bad business decision, financial loss, reputational damage, you name it. And it's almost always linked back to human error, flawed logic, or sometimes just inaction in fixing known issues.
And the consequences can be huge.
They can be astronomical. There are documented cases where single spreadsheet errors, often in complex financial models, have led to losses exceeding $1 billion for major organizations.
$1 billion from a spreadsheet error. That's sobering.
It really is, and it's why it's so vital to be aware of these shortcomings. Not to scare people away from Excel, it's an amazing tool, but to encourage critical thinking and promote best practices. Things like clear documentation, careful error checking, maybe using named ranges, validating inputs, having peer reviews for critical sheets.
So it's about using the power responsibly and understanding the limitations.
Precisely. This balanced perspective helps you manage and verify your spreadsheets effectively, especially when high-stakes decisions are involved.
Okay, so we've really covered a lot today. We've taken this comprehensive journey through the intricate world of Excel.
We really have. We dug into its fundamental anatomy, cells, rows, ranges, workbooks. We looked at efficient data entry using things like the fill handle and custom lists.
Right, then the powerhouse, formulas and functions, relative versus absolute references, the order of operations.
And how to decode those tricky error messages, treating them as clues, not failures, and then polishing it all up with data types and formatting for clarity.
And finally, going beyond the grid with charts and pivot tables, plus how to share your work effectively while also keeping those inherent spreadsheet risks firmly in mind.
It's been a pretty thorough tour.
It has. And the goal is that you, listening now, have a solid foundation to use Excel effectively. Hopefully you can approach those spreadsheets with more insight and less dread. This deep dive is really aimed to equip you with both understanding and practical tools to boost your productivity.
Definitely. But remember, like any powerful tool, this is just the beginning. Excel is vast. There's always more to explore, from mastering more advanced functions like VLOOKUP or index match, to discovering even more ingenious productivity hacks, maybe even dipping your toes into macros or Power Query.
Continuous learning is key. And this leaves us with a final provocative thought for you to maybe mull over.
Okay.
Given Excel's incredible power and, let's face it, its ubiquity, everyone uses it, but also considering these well-documented risks and limitations we just discussed, how do you think the future of data management and analysis might evolve? How can we maybe combine the amazing flexibility and accessibility we love about spreadsheets with the robust controls, security, and auditability we typically associate with databases?
That's a big question. The spreadsheet interface versus database rigor.
Yeah. And perhaps more importantly, what role do you envision playing in that evolution as someone who works with data? How can you leverage the strengths while mitigating the weaknesses in your own work?
That's definitely something to think about. Finding that balance between flexibility and control. It's the ongoing challenge.